Subscribe now.
You are welcome to today's tutorial. For today's tutorial, we are going to focus on how to find the inverse discrete Fourier transform using the Twiddle factor method or the linear transformation method. So as we all know, the x of n is equal to 1/4 over n summation of k equal to 0 n minus 1 s of k exponent j 2 pi over n nk. And then this is what we have done already. And then my previous derivation, we came to the point that our x of n should be equal to 1 over n exponent k equal to 0 n minus 1 x of n, and then omega n, and then we have nk. So based on this, as you can see, there's something wrong with this equation that I've written for the second part. In my previous tutorial, I showed you that when you are finding the Twiddle factor over here, right? This is the forward DFT, and this is the inverse, right? And the inverse, the only thing that I did is to switch the negative sign, of which we call the complex conjugate. So if you are finding the IDFT, the Twiddle factor matrix is supposed to be the complex conjugate, and this sign means the conjugate of whatever is here. But remember that the real numbers they are not complex numbers, so they don't have any complex conjugate, they remain the same. But the numbers that contain the j inside are the complex numbers, so that j, the sign in front of the j, will be changed. That's why in those Twiddle factor about, I reverse the sign on the j. Yes, so this sign means that is our complex conjugate. So based on that, we can also write it in such a way that our x of n is equal to 1 over n, right? And then we are going to get x of k multiplying by the Twiddle factor, but it should be a complex conjugate. So now let's proceed and see something here. So if we are writing the Twiddle factors here using the w as I derived up there, it was w4 power 0, w4 power 0, w4 power 0, w4 power 0, right? And the same thing here is w4 power 0, w4 power 0, and w4 power 0. So if you want to write the rest as I was deriving already, I hope you took note of it. If you don't remember, you can go to those tutorials and rewatch them again. So we have omega 4 of 1, omega 4 of 2, omega 4 of 3. The second one is the multiple of the power over there. Here, multiple of the power over there. Here is 0, right? Multiple, so here is 1 already here. So the next one is omega 4 of 2, omega 4 of 4, omega 4 of 6. And the next one here is also 0. So, and we are done with 2, we are coming with 3. So omega 4 of 3, omega 4 of 6, and then omega 4 of 9. So this is how we do it here. But remember that because they are complex conjugates, we do this sign on all of them. Yeah, we do the sign all of them. So let's head straight into solving some examples. So given an x of k to be equal to 10 negative 2 plus 2j or j2 comma negative 2 minus negative 2 comma and then negative 2 minus j2. Now here, and we are being asked that we should find the IDFT. So if you look at this, this is the answer that we got earlier on. So what we are going to do is that we write down the Twiddle factor matrix. So the way that I showed you, it's 1 1 1 1, and then 1, 1, 1, right? Write your G's. And because it's an IDFT, the backward ones will be negative, the rest remain the same. Sorry, the middle it's 1. So here, -1, -1, the middle is 1. So you are done with it. But remember that it's 1 over n. Don't forget that. And then we multiply by the input, which is x of 0, x of 1, x of 2, and x of 3. And here it's x of 0, x of 1, x of 2, and then x of 3. Yeah, so this is it. So now that we have these values, what we can do is that since it's a 4-point DFT 1, 2, 3, 4, we are going to get 1 over 4 multiplied by this Twiddle factor. 1, 2, 3, 4, j, negative, 2, -1, and 1. And then I multiply by the other one to be 10, -2 plus 2j, -2, and -2 minus 2j. So with this, when you do the computation, you are supposed to get 1 over 4. You can just go ahead and then use your calculator to punch it straight away and write your answer. So you're going to get 10 plus -2 plus 2j minus 2 minus 2 minus 2j. And then the next row is 10 minus 2j minus 2 plus 2 plus 2j minus 2. And then the next one is 10 plus 2 minus 2j minus 2 plus 2 plus 2j. And the last one is 10 plus 2j plus 2 plus 2 minus 2j plus 2. So having this one, you are going to get something like 1 over 4 divided by 4, 8, 12, 16, because here will give us 4, 8, 12, 16. And at the end of the day, because it's an inverse, we divide by 1 over n, and we are going to get our final answer to be 1, 2, 3, and what? 4. Remember here 16. Yeah, that's how I write. So 4. So now this is my final answer for, this is the one that we solved, but then we have gotten it back. So thank you for watching. If you want to solve more examples, you can search online, or the ones that we use the direct computation in solving, and some of them that gave it to you as a practice question, go and pick the answer and then reverse them back using this linear transformation method. Thank you for watching, and see you in my next video.